In this video, we're going to look at a common novice programming mistake in Java, and this is the case of a missing return statement. Here's a typical example of where this kind of mistake can occur. We have a method whose purpose is to return -1 if its parameter's value is less than 0, 1 if its parameter's value is greater than 0, or 0 if its parameter's value is 0, a method we sometimes call sign. Now we can clearly see from the logic that this method is guaranteed to return one of those three possible values. The problem is that the compiler cannot actually work out that there's no way for the flow of control through the method to reach the point that's indicated by the arrow, and the compiler needs to be sure that every route through the method does indeed have a return statement on it and can return a value to satisfy the return type of the method. So the problem is that a method with a non-void return type must return a value for all possible routes through it. And in general, the compiler can't determine whether that's the case or not. It can't analyze the logic and satisfy itself that yes, all possible cases have been covered. And indeed, sometimes as programmers, we do actually forget to include a return statement through a path that could actually be reached. And so the compiler is useful in pointing out to us that there's a logical flaw in what we've written. So even what might be considered as cannot possibly happen routes must be considered. So let's take a look at that in the context of some source code and find out how we might fix it. Here's the code in context, and as we can see, the compiler is giving us a missing return statement error message. The question is, what is it sensible to return at this point? We could simply keep the compiler happy and return the value 0, for instance, and certainly the code compiles now. The problem is that this really doesn't make any logical sense. We know that actually execution can't really reach this point because we've eliminated all of the possibilities, negative, positive, and equal to 0. So the solution is actually to eliminate the final test, which is not required anyway, because if it's not less than 0 and not greater than 0, then it must be equal to 0. This code compiles and in fact is the best solution. The compiler can clearly see that there are only three possible routes through this method, and we've provided a return statement for each of them. Here's a further common example. We've got a search method to look through a collection of student objects to see whether one of those students has a name that matches the parameter that's been passed in. And if we find the student, then inside the body of the loop, we return a reference to that student object. The question is, what value should we return if we fail to find a particular student within the class? We're printing an error message, but that's not sufficient for the compiler. The compiler requires a return statement on every route through the code, and so we must provide a return statement of some sort. Typically, if we don't have an object to return, then what we return is the value null, and that's the solution here. However, it could be argued that we've created this problem by having a return statement embedded inside the body of the loop, and some people would consider this to be bad style. Their preference would be to have a single return statement at the end of the method that either returns the object found or the value null to indicate that nothing was found. So here's an alternative version of the method that adds to the loop's condition the test for whether we've already found the student that we're looking for. So as long as we haven't and the student variable has the value null and there's at least one more item in the list to be checked, we want to carry on the iteration. But either we find the student and assign to the stu variable a reference to that student object, or we iterate over the whole list, fail to find them. Whichever of those applies in a particular case, the stu variable will either have been set to the student that we found or will not have been set inside the body of the loop. So we've eliminated the slightly hidden return statement embedded inside the body of the loop for one that's clearly at the end of the method and easy to identify. So some concluding advice would be to try to avoid multiple if-else conditions without a final else part. And in some cases, when we add a final else part, we realize that actually the final condition we tested is no longer necessary, because that's the only possible case that could now apply, and the value must be true, so we can often eliminate that final condition. We might wish to consider adopting a style whereby we don't embed return statements inside loop bodies, but instead have a single point of return right at the end of the method. That will often require a little bit of work in formulating the loop's condition, but it can result in a logic for the method that is somewhat easier to follow than one in which there is one or more return statements embedded somewhere in various parts of the method. And finally, where there really are situations where we know that a particular path cannot possibly be reached, then we might wish to throw an exception. That's a slightly more advanced topic than we would want to handle in this particular video, but that's an option that's open to us as our Java understanding develops. And at the very least, we should print an error message to say that control has reached a point that really shouldn't ever be reached, and we will still have to provide a return statement in order to satisfy the compiler.